In this video, we're going to cover section 7.2, which is on the addition and subtraction formulas. We have 3 examples we're going to run through. The first one says, use the addition and subtraction formulas to find the exact value of sine of negative 7 pi over 12. To solve problems like these, it's best to recognize what we know the exact values of, as in sine of what angle do we know exact values for. And at this point you should get familiar with, if you aren't already, you should get familiar with the exact values for pi over 6, pi over 4, pi over 3, pi over 2, and then all the way around the unit circle, where the other angles that you would want to know are the ones that have reference angle, those angles I just mentioned, pi over 3, pi over 4, and pi over 6. So I want to write down a few of those for right now. So we know exact values for, and I'll write this out. This is, we know exact values for pi over 6, which is the same as 2 pi over 12. Now, why did I make that conversion to be out of 12? Well, it's because up here, our question says find the sine of negative 7 pi over 12, so everything should be out of twelfths. But moreover, besides pi over 6, we also know pi over 4, which is the same as 3 pi over 12, and pi over 3, which is the same as 4 pi over 12. All right. So how do we solve this problem and find out what sine of negative 7 pi over 12 is? Well, we can write out sine of negative 7 pi over 12 is equal to sine of negative 3 pi over 12 plus a negative 4 pi over 12. And from here, we can use the addition formula So we can use that addition formula to rewrite this as sine of negative 3 pi over 12 times cosine of negative 4 pi over 12 plus sine of negative 4 pi over 12 times cosine of negative 3 pi over 12. Then, well, we know those exact values. Negative 3 pi over 12 is the same as negative pi over 4. If we go negative pi over 4, sine is negative, and it is also the value root 2 over 2. So, in fact, this is negative root 2 over 2. This says cosine of negative 4 pi over 12. That's the same as cosine of negative pi over 3. Cosine of pi over 3 is positive 1/2. Cosine of negative pi over 3 is also a positive 1/2. So we can place that in as positive 1/2. Sine of negative 4 pi over 12 is the same as sine of negative pi over 3, which is in fact negative square root of 3 over 2. And then we get cosine of negative 3 pi over 12, which is the same as cosine of negative pi over 4. So that should be a positive root 2 over 2. Put this together, we get negative root 2 over 4 minus root 6 over 4. So we combine those and we get negative, factor out a negative out of both of those, root 2 plus root 6 all over 4. And there's our answer. All right, so that's the end of the first example. We'll have something not quite similar. We're going to prove an identity here on this next one, but we're going to use the addition and or subtraction formulas. So here we want to prove the cofunction identity. Cosecant of pi over 2 minus u is equal to secant of u. Right? So this one right here. I'll make this a little easier to read. So again, we're going to prove the cofunction identity. Cosecant of pi over 2 minus u is equal to secant of u. To do that, we want to start with the left-hand side here. Cosecant of pi over 2 minus u. And then we want to use our, well, actually, first thing we want to do is rewrite cosecant, because this is 1 over sine. So this is 1 over sine of pi over 2 minus u. And now we can use a subtraction formula for sine. So this becomes 1 over, and then sine of pi over 2 minus u is sine of pi over 2 times cosine of u. I did not need the extra parentheses there, sorry. Minus cosine of pi over 2 times sine of u. All right, we can rewrite this. This is 1 over, all right, sine of pi over 2 is 1. Cosine of u, we'll just rewrite as cosine of u again. Minus cosine of pi over 2 is 0 times sine of u. And if we rewrite all of that, 1 all over, all right, 1 times cosine of u is just cosine of u. And then minus 0 times sine of u, so that goes away. So this is just 1 over sine of u, which is equal to secant. I messed up. 1 times cosine of u, excuse me. And 1 over cosine of u is secant of u. My mistake there. And that's exactly what we were looking for. All right. So we got one more example here. And this last example, number 3, says to find the exact value of the expression cosine of sine inverse of 1/2 plus cotangent inverse of root 3 over 3. So I want to try to solve that. That looks complicated at first, but this has a relatively simple solution. The first thing we want to do is rewrite using our addition formula for cosine. So let's rewrite all of this as cosine of sine inverse of 1/2. This would get multiplied by cosine of cotangent inverse of root 3 over 3 minus sine of sine inverse of 1/2 times sine of cotangent inverse of root 3 over 3. And so we've rewritten this, and again, that looks complicated, but we've dealt with problems like this before, and they weren't that difficult. First off, if we have sine inverse of 1/2, what that means is that the sine of some angle theta is equal to 1/2, right? And sine of theta equal to 1/2, sine is opposite over hypotenuse, so this is 1 over 2 here in this triangle. So this sine inverse of 1/2 is this angle theta. So what is cosine of that angle theta? Well, cosine is adjacent over hypotenuse, So if we knew this long side here, we would know how to write cosine of theta. And, well, this is a right triangle, so in fact we can use the Pythagorean Theorem to figure out this other side length here. So that'll be the hypotenuse squared, which is 4, minus the short side squared, which is 1. So 4 minus 1 is 3, and then we take the square root. So in fact, that long side there is the square root of 3. So we get that cosine of sine inverse of 1/2 is in fact the square root of 3 over 2. Okay, we're going to do the same thing for cosine of cotangent inverse of root 3 over 3. What does that mean? And that means there is some angle theta where cotangent of that theta is root 3 over 3. Cotangent is adjacent over opposite. So adjacent side is here, opposite side is here. Again, we can use Pythagorean Theorem to find out the hypotenuse. And that is 3 squared plus the square root of 3 squared. 3 squared is 9. Square root of 3 squared is 3. So 9 plus 3 is 12. And of course, we take the square root of that. Again, I just applied the Pythagorean Theorem there. Right? Just as a reminder, in case the Pythagorean Theorem was a squared plus b squared is equal to c squared. And c squared is just the length of the hypotenuse. C is the length of the hypotenuse. C squared, in this case, would have been just 12, because squared is 12 squared. A and B are just the side lengths. Just as a reminder, just in case. But that's where I was getting the information from these triangles from. But anyways, going back to filling out what we're trying to do up here, we're trying to find out what this expression here is. We knew that cosine of sine inverse of 1/2 was square root of 3 over 2. So cosine of cotangent inverse of square root of 3 over 3 is in fact the square root of 3 over square root of 12. Okay. Then, what is sine of sine inverse of 1/2? Well, sine and sine inverse cancel each other. So sine of sine inverse of 1/2 is just 1/2. To figure out sine of cotangent inverse of square root of 3 over 3, well, we had already filled out the triangle for cotangent inverse of root 3 over 3. That was here. So I'll rewrite that. And now we want to do sine on that triangle, sine of this angle theta here. So that is opposite over the hypotenuse. So that is 3 over the square root of 12. So we get square root of 3 times square root of 3 over here. That's just 3. You get a minus 1 over 3. So it's a 3. Minus 1 times 3, excuse me. So it's 3. All over 2 square roots of 12. The denominator was the same in both of these. So we can go ahead and combine those fractions, which I've done here. 3 minus 3 in the numerator is 0. So in fact, we get 0 for this expression. And that is it. That is all of the examples I have for section 7.2.